once again, and we want to welcome you to this, our second night in our lecture series under the theme Back to the Beginning, hosted by Project Probe Ministries. And in case there are any of you here who are not yet aware, Project Probe Ministries is a Christian apologetics organization which has been operating in Barbados for the past 14 years. And we facilitate lectures and discussions on important issues of controversy to the Christian faith, which at the same time caters to the general public. Last night, our guest speaker, retired Associate Professor of Physics, Dr. Russell Humphreys, presented a sampling of the tremendous amount of scientific evidence that the world is really thousands of years old, in keeping with the biblical worldview of origins, and not billions of years old, as advocated by evolutionists. If you missed or did not miss that lecture, you may want to sign up for a DVD copy when it is available. You can do so at the table at the entrance of this conference room. You can just sign up, give your name, the title of the DVD you would like to get, the title of the lecture you would like to get, your telephone number, your email address. Additionally, if you have not already done so, you can also pick up a copy of the pamphlet, Evidence for a Young World, which itemizes the evidence presented in last night's lecture. Given such scientific evidence for a young world, and given the fact that the furthest confirmed galaxy photographed by the Hubble Space Telescope lies about 13.1 billion light years from Earth, the logical question is, if the universe is young, how can we see so much of it? Tonight, Dr. Humphreys will address this really big question in his lecture, Starlight in Time, How We Can See Distant Starlight in a Young Universe, after which he will address your questions. And the Q&A session will be moderated by our moderator, Mr. Steve Ski. We now call on medical practitioner, Dr. Elvis Wickham, to once again formally introduce Dr. Humphreys to you. Thank you.
Good evening once again, ladies and gentlemen. It is indeed my pleasure to again formally introduce Dr. Russell Humphreys. Dr. Humphreys was born in Michigan, USA, and raised in a non-Christian home with very scientific parents. He received a bachelor's degree in physics at Duke University in 1963. After this, he moved to Louisiana State University to study postgraduate physics. He was an atheist up until 1969 when, at the age of 27, while doing his dissertation research for LSU in the mountains of Colorado, he committed his life to Christ. He, however, only became a creationist about a year or so later because up to that time, he had no explanation for the billions of years in age the Earth was supposed to be, the universe was supposed to be, yet, according to the Bible, it was very young. In 1972, he was awarded a PhD in physics on cosmic rays and ultra-high energy nucleon-to-nucleon interactions, by which time he was a fully convinced creationist due to both biblical and scientific evidence. Dr. Humphreys has a lot of hands-on physics practical experience. After postgraduate studies, he initially worked in the high-voltage laboratory of General Electric Company, designing and inventing equipment and researching high-voltage phenomena. Beginning in 1979, he worked for Sandia National Laboratories in New Mexico in nuclear physics, geophysics, pulse power research, and theoretical atomic and nuclear physics. Dr. Humphreys has also researched extensively in many areas and has numerous published papers as a result. He has also been a graduate school professor in physics. In 2001, he retired from the Sandia National Laboratories and subsequently worked full-time for the Institute for Creation Research. He has also done work for Creation Research Society. Dr. Humphreys retired fully in 2008, but continues to do creation research, writing, and speaking, mostly on his own, but sometimes for creation societies. Ladies and gentlemen, it is my distinct pleasure to introduce to you tonight's speaker, Dr. Russell Humphreys.
Well, thank you for coming out. I think I warned the audience last night that this one is the most difficult of all the different seminars that I give. And that's because even though I try to use simple words, the concepts of cosmology are really difficult for people who haven't spent a little time looking at them. So I ask that you gird up the loins of your mind, like Peter said, and try to hang on, and I'll do my best to make it clear, but there are going to be some bumps in the road. So let's see if we can get the computer to show our slide. Let's see, I know what the computer's doing wrong. Okay. The light years are not a problem. That's the bottom line of what I want to get across to you. Not a problem for the believer in the young world of the Bible. The perceived problem is the short time for light to get here. So creationists need a brief history of time, or rather we need a history of brief time. How many of you have seen Stephen Hawking's book, A Brief History of Time? Oh, good. That's good. Some of you won't have too much problem with some of these weird concepts. But we need a history of brief time. So one thing that's going to help those of you who are familiar with Scripture is that I'm going to use a lot of Scripture to build this cosmology on. By the way, this is the second cosmology that I've had. The first one in my book, Starlight and Time, came out in 1994. This one is a newer one that hasn't been written up in a book. It's been written up in a technical journal. But this one came out in 2008, and there's a third one in the works. So this is a work in progress. But let's go back to what a biblical cosmology should explain. It should explain how light got here fast. It should explain the similarity of galaxies near us and far away. They look pretty much the same, and I'll show you a picture from the Hubble Space Telescope. Then all cosmologies should explain the redshifts of distant galaxies. The further a galaxy away from us is, the more to the red its spectrum of spectral lines is shifted, and it seems to be proportional to their distance. So Hubble observed that back in 1929. And then a thing called the Pioneer anomaly. That is something having to do with the Pioneer space probe, and when we get to that point, I'll explain what that is. Some of you probably have heard of that. But our starting point is the Genesis deep. So we're going to Genesis 1:2 now. What was the deep in Genesis 1:2? And here's that verse for you. And the earth was formless and void. Darkness was on the face of the deep. You notice that? And the Spirit of God was moving over the face of the waters. Now, that last word is a little clue as to what the deep might be. The deep has a face and it has waters. Henderson, I can destroy that for you real easy if you want. So another clue about what's going on is this little word over. If there's an over, then there's an under, and there's an up and a down. So gravity was at work. In fact, to have real water, and that's what I think God means when he says water, you have to have all the laws of physics functioning to get water molecules and atoms that are in the molecules. So another clue is face. That means the surface. You know, if you just throw a bunch of water out in space with no gravity, it will have a very fuzzy interface. You can't tell whether there will be a surface or not. But if there's strong gravity going on, then the water will pull into a blob and it will have a surface. You with me so far? You didn't think you could get so much out of one little verse. Okay, so here's my answer for what the deep was. It was a big ball of water. And you deduce ball from the fact that there was gravity. If you let gravity do its job, it will pull the water into a spherical surface, into a spherical ball. And we'll learn why it was big in the verses to come, but it had to be much bigger than the Earth, many, many light years in diameter. And the Earth was empty of any special features. That's the formless. And void. It didn't have any inhabitants. One person translates that formless and uninhabited. The formless and void are without form and void. So now let's move on to the next few verses. The heavens originated in the deep. That may be a surprise to you. And God said, let there be an expanse, that's the modern translation, or a firmament in the King James, in the midst of the water. So down in the middle of that ball of water, there's this black stuff, which is like empty space, just like the space around it. And so what's a firmament, or what's an expanse? Rakia is the Hebrew word, and the Greek Septuagint translates that word stereoma. And the Latin Bible made by Jerome, the Vulgate, translates it firmamentum, and the English Bible, the King James, translated firmamentum. They didn't really translate it, they just transliterated it, called it firmament. And as far as I know, that was not a word in the English language until that point. But basically, it means something spread out. It can be a solid something, but it's a something that's spread out. And so there is, well, I won't go into that. You're confused enough already. I won't go into one little interesting side branch there. So now, what happened with the expanse that God made? You notice it's in the midst of the water, so I couldn't draw a really tiny black line down in the middle. I had to give it the inside part just a little bit of size, but really it's a lot smaller than the rest of the ball of the water. So now what happens with the midst of the waters? That will be important in a moment. And God looks like He expanded the waters. So that's where the spread out idea comes from. And you notice I have it's big enough for the stars, big enough for all the galaxies. So this is a really big thing. I couldn't draw it to scale. But above the waters, above the expanse, there are some waters. And down in the middle, there's a small ball of waters. And you'll see why it's big enough for the stars in a moment. So basically what the Bible says is beyond the stars is water. By the way, just to make sure we understood what the expanse was, God called the expanse heavens. So these waters above the heavens will turn out to affect us here. So here's a big thing. It looks solid in my picture, but imagine it as a thin shell of just ice crystals. The ice crystals aren't connected. It's just a spherical arrangement of mostly ice crystals, maybe large planets covered with ice and inside water. And you notice that the scale, it's greater than 24 billion light years. Now, where do I get that? I get that from the fact that the Hubble Space Telescope can see out nearly that far, 12 billion light years and a little further, and there's no sign that we have of the waters or any sign of the galaxies stopping and reaching empty space. This is probably as thin as the ice particles in the rings of Saturn, or even thinner. So you might not be able to see it in the Hubble telescope if it could see that far. But because the area is so big, there's a lot of total material mass in that spherical shell. Now, why am I so confident that there are waters above the heavens? The answer is there's a verse. Psalm 148:4 says, "Praise him, sun, moon, and stars. Praise him, highest heavens, and ye waters that are above the heavens." And those are still there. Some people like to have the verses talking about waters above the heavens be waters just above the atmosphere and collapsing to make some of the water of the Genesis flood. But these are out above the highest, farthest stars, so they couldn't collapse upon the earth. Now, the earth is near the center. That's another important thing if you're going to make a biblical cosmology. This little verse in Genesis 1:9, "Let the waters below the heavens be gathered into one place." So I've shown a ball of water here. And let them be gathered into one place, and let the dry land appear. So if you keep your eye on that, we'll see that process. The bowl of waters is now turned into dry land and seas. It's become the earth. Now, remember where that ball started. It was in the midst of the waters, roughly near the center. Hebrew word just means pretty much at the center of things. Now, this was on the third day of creation that he made the land and the sea and the earth in that form. There were no stars or planets yet. So at the start of the fourth day, the earth was the only matter, the only stuff below the waters. So here it is, tiny little. I couldn't make it to scale, of course, and I couldn't make that thickness as small as it is on that scale. But the waters are way out there. You got that? That's now. This makes for an unusual gravity situation. Here's what's important about gravity in all of this. I'm going to tell you why gravity should matter. Scientists agree that gravity affects time. Now, this is one of the mind-blowing things. If you're not familiar with relativity, there's this feature of Einstein's general theory of relativity. You know, he had a special theory that talked about velocity time dilation, moving fast and things shrinking and clocks slowing down. But in his general theory, that one talks about gravity. And that one has a feature called gravitational time dilation, or time stretching. And the bottom line of this is that the lower a clock is, the slower it should tick. So I've got a slow clock down here and a faster one on top of the building. Lower clocks tick slower. Now, this was predicted by Einstein before anyone ever measured it. but it's shown, solidly shown by experiment. So what this means, clocks register time. So if a clock has been slowed down just by gravity, that means all time is slowing down. All physical processes would be slower. So what that means is down here at sea level, you're getting older, not as fast as somebody on a mountaintop. You should like that. Now, they've measured this with atomic clocks, which are very precise, and the difference isn't big. So the atomic clocks of the National Bureau of Standards in Boulder, Colorado, those are at 5,000 feet above sea level. And they tick about 1/millionth of a second slower, 1/millionth of a second faster per year than clocks at sea level. It doesn't sound like a lot to you, and I wish my watch were that good, but it is very noticeable to these guys. They can measure time very precisely, and that's a big, it's a big noticeable effect, and it makes a problem. How are they going to synchronize their clocks with other clocks around the world, with other bureaus of standards and so on? So they know this. Now here's a way just to remember which is fast and which is slow. Little rhyme maybe. Time flies when high, and it's slow when low. Flies when high, slow when low. Okay. Now here's an analogy to help you picture gravity and then its effect on time. A trampoline. It's a good analogy for gravity. So imagine that our universe were, completely flattened out into a two-dimensional plane, okay? And we'll just ignore the third space dimension in our universe and just forget it. So this is an analogy to help you understand gravity. Now you notice where the girl is standing on the trampoline, there's something under her feet. There's a dent there. And that dent has to do with, it's an analogy for the effect of gravity. So if we imagine the waters above the earth, they would be two-dimensional in this analogy, and they're like a ring on that trampoline. So, we've done away with one of the dimensions, so that spherical shell of water is now like a ring. So imagine a heavy iron ring sitting on your trampoline. Now inside the ring, if you ever actually do something like this, you'll notice that inside the trampoline is flat. So if you put a marble on the flat part, that marble wouldn't want to roll in any direction. That corresponds to no gravity, no forces of gravity inside the ring. But if you put the marble outside the ring, it's going to want to roll down the trampoline toward the ring. You with me? That's the force of gravity from the waters above outside the ring. So a little mass makes a little dent in our trampoline. And what about a really big mass? Oh, let's see. The waters above made a very deep dent. So the depth of the dent in the ring corresponds in the equations of physics to the energy associated with gravitation. So the deeper the dent, the more gravitational energy difference there is between the bottom and the sides. So mass, by the way, just means, is what we call it. Mass just means amount of matter. So the mass of water, I have from another bit of information I've been working on. The water mass is about 20 times the mass of all the galaxies. And I get that from the Pioneer anomaly data, and I'll talk to you a little about the Pioneer anomaly later. But it's in the Journal of Creation, August 2007. If you go to creation.com, you can see back issues of the Journal of Creation. It's a technical journal, and it's a technical article. So now let's look at the cross-section of this trampoline right here. So we have gravitational energy plotted here, and distance out from Earth, this little dot here, out radial, along a radius line. And on the fourth day, the Earth, this is one part of my cosmology that's just a plain old assumption. I'm assuming that the Earth was just above a certain level that the equations give you, at which funny things happened at time. So you notice this little dotted line here. That's at a certain depth of gravitational energy, and it happens to be 1/2 the speed of light squared. And that enters into the equations, and funny things happen. And I called it a timeless zone. So what I mean by that is if we push the trampoline down below that dotted line, clocks would stop ticking altogether. There would be no time. That's the only way I can understand the equations. I may be wrong about that, but that's the thing that makes the most sense about the equations. I don't think you want me to give you the equations, do you? No, okay, I won't inflict those on you. So some of you have problems with graphs, but I'm sorry, if you don't want equations, graphs are about the only way to say some things. So out here at the center of our trampoline is the Earth, and it's making a little bit of a dent, and it's just above that dotted line. And then out where the waters above are, where the ring on the trampoline is this point. And then after that, the trampoline starts rising up. But it's mostly pretty flat here, so even the waters above are not far above that critical level of energy. So I defined what timeless was for those of you who are interested in the gory mathematical details in another Journal of Creation article in August 2008. So next, let's make a cross-section of the cosmos. We'll start building toward that, a cross-section of the cosmos when God made the stars. On the fourth day, God created the stars. So here I'm showing the Earth, much bigger than it would be on that scale, and some galaxies that God has created right around it. So I'm going to imagine, this is another assumption, that God created the galaxies in a spherical wave expanding out from the Earth's vicinity. So it would look like this. So we're looking down on the trampoline. So we'll see that wave of stars being made here. And by the way, this is the verse that's important. God made the two great lights, and then it said some more things, and then he made the stars. And God placed them in the expanse of the heavens. So that's how I know the expanse has to be large, is because he put the stars in it. Okay. So, now let's make our wave of stars. I'll run the animation again. See them spreading out. Okay. So new stars are like little tiny weights sprinkled on the trampoline. Think of them as lead BBs or something. The new stars mean more gravity, and they do something to the trampoline, and they affect the zone of timelessness. So we're going to have, I'll just show you, and I'm not explaining the physics here, I'm just showing you the results. So let's show a zone of timelessness here. Again, we're at a cross-section. These new star masses would dent the trampoline. So here we have the trampoline with just the Earth and the waters above on it, and it's practically flat. Now we're adding a wave of new stars. It makes a dent, sort of like that. It might have a somewhat different shape, but generally like that. So that is an additional dent, and you notice the dent went down below that special dotted line. And notice, I'll run it again. Notice which parts go under the dotted line first. The one is near the center where the Earth is. Okay, now let's add another scriptural effect, stretching out the heavens. If you pull on that trampoline, if you were to somehow tighten up the screws and add more tension to it, it would stretch it more. And there's scriptures that indicate that God stretched the fabric of space. By the way, according to Scripture and modern science, space is some kind of stuff, and Scripture compares it to a fabric. And how do I know that? Well, there's lots of verses in the Old Testament, like this one, similar to this, that says, God stretches out the heavens like a curtain, or spreads them out like a tent to dwell in. So he's here comparing it, the space itself, to like a curtain. It's like the fabric of our trampoline. So here's another cross-section of the trampoline. But watch what happens to the trampoline when we increase the tension in the fabric of the trampoline. Okay? We're increasing the tension. It makes the dent shallower. You see that? It pulls the dent up. So that has some effects on time in our timeless level. So stretching raises the dent back up above the timeless level. So the stars made an additional dent and pushed everything just below the timeless level. But now we're going to stretch the heavens, apply tension to them, and watch this little intersection between the blue line and the dotted line. That's one name for that is, if you've read Hawking's book, it's called the event horizon. Black holes have an event horizon around them, and this is a very similar effect, except we don't have strong gravitational forces. We have weak gravitational forces because this blue line has a very small slope. So the event horizon is where time stops. And you're going to see it move inward as we stretch out the heavens and pull that dent upward. So it's going to move inward. And just watch it now as we do that. You see that? I'm going to run that again. Watch the event horizon move inward as we pull, apply tension to the trampoline fabric. Okay? So that's an important thing to get in your mind. So you can visualize all this, I think, okay. Now, let's again look down on our trampoline and look as God made the stars. And this time we'll show the effects of the timeless zone. So remember I'm suggesting that he made the stars in an expanding wave of creation. But now you're going to see something following that wave. So here we see the new galaxies that he's started to create on the fourth day. And you notice there's no green dot in there. So it's already had its clock stopped. And now you're going to see the stars being made in a wave just like before, but behind it, there's this black zone right here. It's going to expand out and follow it. And then when it reaches the edge and things happen out there, it's going to turn around and recede. So, And that's because of the stretching takes over. So first, there's the weight of the stars pressing the trampoline down, but then after a while, the stretching takes over and pulls the trampoline up again and shrinks the timeless zone. So here's the animation of it. See that black zone? That's the timeless zone. Now the stretching has taken over and it's shrinking the timeless zone. And boom, the last thing to emerge from the timeless zone is the Earth. So all that time, the Earth has had its clocks stopped the longest. Everything else has experienced more time, maybe billions of years worth of time. So let's take a 3D view of the timeless zone. Starlight followed the shrinking zone as it started moving back in of timelessness, and I made the timeless zone purple so you could see it. It would really be just black. So, that's kind of hard to see against a black background. But outside it, you see an actual Hubble Space Telescope photo of a lot of different galaxies. Those are real galaxies. So now watch the sphere shrink. So as it shrinks, more and more galaxies pop out of the sphere. And their light is going to go in all directions, and some of that light will follow the shrinking sphere inward. Keep on following the shrinking sphere inward. So when the sphere completely disappears and the Earth pops out of it, all that light that's been following from those very distant galaxies will suddenly appear. So let's see what this means. It means that Earth time stopped at some point during the fourth day. So let's say you were on the backside of the Earth and the sun, the newly created sun and moon were on the other side, and you wouldn't see any stars. Maybe you would see a planet or two on the night side at that point. But all of a sudden, at one point, time stops. You don't feel a thing. You would be stopped too. So I don't think you would experience anything, but there were no people present, so it probably doesn't really matter. And then, all of a sudden, boom, the night sky lights up. There's lots of stars, and even you can see our nearest neighbor galaxy, Andromeda, all of a sudden, boom. So as far as the Earth is concerned, all of that light got to us in no time at all. So that's a bit drastic, I agree. But anyhow, then time goes on the Earth, and it lasts fourth day. So God has gotten the light to us during one ordinary day. The fourth day was only 24 hours here, and starlight arrived in one instant sometime during that fourth day. I think it was maybe toward the end of the fourth day after he had made all the stars. So there's this little verse that tells us something very important about starlight. It said, on the fourth day, he said, "Let there be lights in the firmament," or in the expanse, "to give light on the earth." And then he says a few more things. And then he says at the end, "And it was so." So his purpose was to get the light from those distant stars that he made on the fourth ordinary day, ordinary length day, let's say, here. He wanted that light to arrive here on that day. So that's the "and it was so." So even if my cosmology is completely bonkers, somehow God made that happen. And there are other cosmologies of creationists to choose from if this one doesn't appeal to you. But the bottom line is, God wanted Adam to see the Milky Way, parts of the Milky. I understand on a good night you can see the Milky Way here, is that right? Yeah, I envy you. I can't. There's too many city lights where I live, and I miss seeing them. Used to see them out in the west, especially on mountaintops. But so anyhow, God wanted to see the Milky Way. There are parts of the Milky Way that are 50,000 light years away from us. And Andromeda, this is a picture of the Andromeda galaxy. To the naked eye, it looks like a blurry haze about the size of the moon in the northern part of the sky. If you put your binoculars on it, a good set of binoculars, you'll pick up some of the structure of this spiral galaxy. So let's move on and kind of summarize all this. During the fourth day on Earth, billions of their years way out there elapsed in the distant sky, but all during one ordinary day here. So the age of the universe, when Adam and Eve saw it, was 6 days EST, Earth Standard Time. So, and the reason I make a little joke about that is because God set up time according to our frame of reference. At a couple of church talks, I'm going to emphasize how he emphasized that there were ordinary days here, but there's a verse there in Genesis 1 that said he set everything up to mark off days and years and signs and seasons. So he was giving us time in our frame of reference locally here. So when he said he made the whole universe in 6 ordinary days, that's Exodus 20:11, for Jehovah, in 6 days, Jehovah made the heavens and the earth, and the context there is ordinary days of the week. So, but it's our time here. So today, the universe is 6,000 years young as measured by clocks here. And that brings up an important thing. People always ask you, how old is the universe? And some of them may be skeptics when they ask that. They may think they've got you in a corner. But remember that time doesn't tick at the same rate everywhere, especially on the fourth day of creation. So you should say back to your skeptic friend, by whose clocks? You want to know how old the universe is? By whose clocks should I give you the age? I guarantee you that will set him on his heels. So I like to rehearse the audiences just a little, so when the time comes and the skeptic asks you, you'll remember this, okay? So I'm going to be your skeptical friend, okay? And I'm going to ask the question, how old is the universe? You should answer, by whose clocks? So say it good and loud when we get to that. Okay, I got you now. How old is the universe? He's blown away. I guarantee you he will have never thought of that angle at all. Okay. Now, let's get to something interesting about cosmology that a lot of people don't talk about. The Big Bang theorists don't talk about this. And that is that distant galaxies look pretty much like nearby ones. This is the Hubble Ultra Deep Field camera. They pointed the Hubble telescope at a really empty-looking spot in the sky and left the exposure on a long time, and they started to see galaxies. And even the tiny little dots, you can barely see them there. Those are galaxies, but the nearer ones, you can see some shape to them, and they look pretty much like nearby galaxies. There's not a lot of difference. Well, according to the Big Bang Theory, the further out we see galaxies, the younger they should be as we start to approach the time that they were formed. But as far back as we can see, and there's another deep field that goes even farther than this one, as far back as we can see, Roger mentioned one galaxy that was 13.1 billion light years away, according to its redshift. As far back as we can see the shapes, they look pretty much like our galaxies nearby, and our own galaxy even. So that's a problem for the Big Bang. And by the way, the spiral galaxies all look wound up about the same length of time. Last night I talked about spiral galaxies winding themselves up. That's sort of like a clock on a galaxy. And all of the galaxies that we could see look, a few 100 million years old by their clocks. That much winding and no more, and no less either. So they all look to be about the same age. And so that's a problem for the Big Bang theory, and I'll talk about that tomorrow with the Big Bang theorists at our discussion, our panel discussion at the other church or another place. So anyhow, what we see here agrees with this view of creation that I showed you, but it disagrees with the Big Bang theory. Okay, what about those famous redshifts of light from distant galaxies? Stretching of space can cause the redshift. If the stretching makes the space really expand a lot, that would explain the redshift. So I'll show you how that works. So here's a verse. God stretches out the heavens like a curtain. Okay? And so imagine a light wave embedded in that stretchable material. So I'm sort of imagining it like rubber, that you can really stretch it. If tension gets applied to it, it will get bigger. So this is one explanation of the redshift. So you've got the light waves embedded in the fabric of space. Now it's stretched the fabric of space. Imagine it's sort of like spandex. Okay? You stretch out the wave along with it. So the wave will have a longer wavelength. It'll be redder than it started. So here's the spectrum that astronomers observe from galaxies, and I'm going to show you the spectrum and then show you what happens as we back away from the source, as the distance increases. So what they see is a rainbow. That's a continuous spectrum, but in it there are little black lines. Those are called absorption lines, and those come from hydrogen atoms in the line of sight absorbing that background light behind them. So you're going to watch those lines move toward the right-hand side as we back away from the source. So that's the redshift. Of course, they don't see the action that I showed you, but the further away a galaxy is, the more those absorption lines are toward the red end of the spectrum. You may not have known exactly what they meant by redshift. That's what they mean. And this would happen if the heavens could stretch out a whole lot. Now, I have to say to you that I'm not sure the heavens actually expanded that much. I do think that, my friend John Hartnett, who has another creationist cosmology, and I'll show you his book in a moment, and his is good, but he thought of something a few years ago. Like me, he thought stretching out the heavens would make the redshift. But then he said, we're not paying attention to the other part of the verse. Like what? Like a curtain? And elsewhere there are other comparisons to fabric of various sorts. But in Old Testament times, there was no real stretchable fabric. There were no rubber sheets. And even nowadays, most fabrics can't stretch out very much. You can apply tension to them, and you get a lot of effects just from applying tension. But if he really means the heavens are a lot like a curtain, like a fabric, it may not be a stretchable fabric. And so then we have to look for another explanation for stretching out the light waves. Fortunately, there are other things that would happen. Just the change of the trampoline depth as we increase the tension on it could do it. So I'm working on a third cosmology to try to take care of this. And John's cosmologies also depended on a lot of space stretching, and so he's also back to square one on that point. But the rest of what I've been telling you would still work. So it's just that we would have a different explanation of the redshift than this. So it's a work in progress. I'm not claiming to know how it actually happened. I'm just looking for the most plausible way to explain what we do see. Now, stretching affects things nearby, it turns out, or applying tension to the fabric. See, let me back up a little bit. He said we stretch out the heavens or spread them out like a tent curtain. In the tabernacle, the outer curtain fabric that was applied to the tabernacle was stretched over the framework and pulled taut so it wouldn't flap in the wind. So it's applying a tension, but it's not really necessarily getting very big. But just applying the tension will do that pulling up of the, making the gravitational well or that dent in the trampoline less deep, making it shallower. So it affects the effect of that dent, and the decrease of the dent depth explains the Pioneer anomaly. So now it's time for me to explain what that is. There are two of the Pioneer spacecraft, Pioneer 10 and Pioneer 11, and they went out in opposite directions, and they are now at twice the distance of Pluto from us. They're way out there, and until they shut down the project and shut off the transmitter of the Pioneer, it was broadcasting signals back. So Earth would send a radar pulse out to it, and it would send back immediately another pulse back to Earth. So it's sort of like a radar measurement. And so they continually measured the time with which these pulses bounced back and forth, and they got the distance. And of course the distance is increasing as these things are moving out there. But they observed an anomalous thing, something that didn't quite fit anything they could understand. It's a slowdown of these space probes. The space probes, of course, attracted by gravity, attracted by our distant sun, and all sorts of things. But they couldn't account for one part of the slowdown that they saw. And that was the anomalous part. It wasn't much, but they watched it for 20 years. And the velocity continually, the deficit in what the velocity should be and what it was according to the radar measurements kept getting bigger and bigger. So that deficit they call the Pioneer anomalies. Something was anomalously slowing down those space probes more than they should have. And so there are all sorts of theories that came out about this. But I think it's just a relativity effect. It's just the effects that would follow that dent in space-time getting shallower. And so I wrote about that in the Journal of Creation in August 2007. Now, since that time, somebody, Russian, who was on the original Pioneer project with Jet Propulsion Lab, his name is Slava Turashev, a couple of years ago and said, well, maybe parts of the space probe are emitting more heat radiation in the forward direction than they are in the backwards direction, and that would, he did some heat calculations but he didn't give any of the details in his paper in the physical review letters. He just showed the results. He showed the temperatures on the surface there, and he claimed that this would make enough heat radiation to slow it down by the observed amount. And he promised, I wrote him shortly after that, sent him an email, and asked him if he was going to have another paper giving the details of his heat calculation. And he said he was planning to do that and was even working on that. And I waited a year and a half, and the paper didn't appear. So I wrote him again last year, last spring of 2014, I think. And I asked about what he had promised to do, and he said, well, I'm not going to do it anymore. I've just decided to do other things, and I don't want to give the details of my heat calculation. Does that sound a little peculiar to me, you know? Why would he change his mind about that? Because everything depended on the details of his heat calculation. If it wasn't right, his explanation for the slowdown wouldn't work. So I took the data he had in his paper about the temperatures of all those structures, and there's a real simple formula you can use from physics to tell the power, the wattage of the heat radiation from those surfaces. And lo and behold, it was less than a few percent of what's needed to slow down the space probe. So there's something wrong. Either his temperatures are wrong, or his computer simulation had a glitch in it and didn't calculate the radiation right. And I think he found it. I think he found some glitch. And so he's not going to go any further because everybody already accepted his paper and thought it was just great. And those stupid creationists, they were aware of the creationist calculation. A lot of people were, because creationists were kind of shoving the paper under the noses of some of the experts at JPL and so on. So anyhow, I think he made a mistake. And someday I hope to just kind of elucidate what I just told you about the radiation not being nearly enough. It's on my pile of things to do. So I too have priorities. I guess I can't really criticize him for having a priority like that. So here's a layman's article you can read about the cosmology I've told you about. The summary is at creation.com. This is a great website, by the way, a tremendous creation resource. And it has a search engine up at the upper right-hand side, right there somewhere. And if you just plug in new creation cosmology into the window there, you'll get a short layman's description of this cosmology. That's the only thing that's out there. There's not a nice Starlight and Time type of book. And I probably won't write that. I'm going to wait until I have my third cosmology, and then maybe I'll have all my ducks in a row. But here's two technical journal articles on the cosmology. In the Journal of Creation, which you can get at that same website, creation.com, and you can read back issues in it for free. Here's the one on the Pioneer anomaly. Creationist cosmologies solve Pioneer anomaly. The editors had no doubt that I'd solved it, so they were very confident. And then this is December 2008 issue, August 2007, December 2008. And right here is New Time Dilation Helps Creation Cosmology. So this is talking about that timeless zone and outlining this cosmology I've just given you. So that's for the techies among you. Now here are some books that would be better. By the way, creation.com, great place. There are 4 young universe cosmologies right now. This is my first one, Starlight and Time. and a nice video about that with some great animation in it. And then my friend John Hartnett has a pretty technical book. There's a lot of equations in this, Starlight and Time and the New Physics, and he outlines one of his cosmologies there. He has two. He liked this one better, but this one depends heavily on expansion, and now he thinks there hasn't been much of an expansion, so now he's back to square one, too. And then here's a great general book by him and a good technical writer, a good popular science writer, Alex Williams, called Dismantling the Big Bang, God's Universe Rediscovered. So this is probably a good book. You can find that on all the creation websites and creation.com also. Dismantling the Big Bang by John Hartnett, Hartnett. And that's at creation.com too. So all of these, the four cosmologies you could pick from use general relativity and gravitational time dilation. Here's a video discussion of two of them. The one I just outlined to you, and the one that John Hartnett used to like of his own. And it's called Distant Starlight, a Forum. And it's Humphreys and Hartnett, and we're on the same stage together and presenting our two cosmologies, and audiences seem to like it because here are two ornery owl hoot creationists, and they like each other and get along with each other. And even, John said he liked my cosmology, and I said I liked his cosmology. So that's a unique feature, two creationists actually agreeing on something. Okay, let's summarize. By the way, that's at creation.com, as well as some other creation websites. Creation cosmology is answering questions, and then I'll answer yours right after this. It's answering, trying to answer how light got here, and the similarity of distant galaxies to recent galaxies, near and far, and redshifts of galaxies, and how the expansion affects spacecraft. So we're pretty sure, by the way, that Pioneer anomaly has something to do with the expansion, because there's a constant in cosmology called the cosmological constant. It's symbolized by a big H. And if you multiply that number by some speed, you will get an acceleration or a deceleration. And if you multiply it by the speed of light, you get just about exactly the amount of deceleration that the Pioneer sees. And so that's explained by my explanation. It's not explained by Slava Turashev's. So anyhow, it looks like there's something going on with a decrease of that dent in the trampoline, relativistic thing going on. So why am I burdening you with all of this? I want you to trust the Bible to be true. And this thing about how the light from the distant galaxies gets asked all the time. There was somebody who asked it last night in the question-answer session. So I hope he came for this answer. I told him we'd talk about it here. Well, thank you very much for your attention. You've been marvelous in enduring all this.